Hello and welcome Math 130 students. We are going to pick up on page 20 for Math 130, so section 2.6, which is function notations. So when a function is defined by an equation, we often use function notation. So we have an objective to write functions using function notation. So remember how we used to have a linear equation that y is equal to mx plus b? Well, now instead of saying the y, we say f of x. The reason we changed the y to the language of f of x because now we are specifically talking about a function. Remember, a function is that exactly one member in the domain, which is an x, has exactly one value in the range, which is your y values. So remember, the x values do not repeat. And of course, there's more to just x values don't repeat, but that's just something quick that maybe should trigger some memory of what a function is. Exactly one member in the domain belongs to exactly one member in the range. So here, changing that y equals into f of x, we can put that into an example. So for number 1, it says for the function f of x, evaluate f of 6. So you might be thinking, okay, like what exactly is f of 6 really saying? Well, this is saying from the function, we let that x is equal to 6, and we want to find your y value. Okay, so you guys remember your y value. So before, in previous chapters, we had that y was equal to mx plus b. So y was equal to, your slope, the x-coordinate plus the y-intercept. So now it's saying, hey, we actually have the equation that y is equal to a negative 7x minus 5. So wherever we see this, x value, we are going to plug in this value, and this value is going to be 6. So now you, the students, say, okay, this is y is equal to negative 7, and then the x value that we're plugging in, it's 6, because we were saying, at the x value is equal to 6, plug that in, and we still have a minus 5. So we can plug that into your calculator, so we can have a negative 7 times 6 minus 5. That's going to give you a negative 47. So now we want to rewrite this answer using our function notation. So when we rewrite this using our function notation, we say that if we have our function and we plug in 6 for x, then my value is going to be a negative 47. Okay? So if you're like, wait, what does this really mean? It says then x is equal to 6, then you figured out that y was equal to a negative 47. So you figured out the order pair 6, negative 47 as a solution to this equation because they had given you the x value. So now for the second example, it says evaluate g of 8. So of course now this is saying that our x value is equal to 8 and we want to find the y value. So we have that y is equal to, remember we have our negative x plus 3, 6x plus 5. So when we plug in that value for x, and x, I'm just going to put parentheses around it so you know that's where I'm plugging it in. And I'm plugging in this x is equal to 8. So when I plug 8 in, this is what my equation is going to look like. And if you guys want, you can put this directly into your calculator, or you can just simplify it. So if I were to have a negative 8 plus 3, that's going to give me a negative 5. 6 times 8 gives me 48, plus 5 is equal to my 53. So now I have my fraction of negative 5 over 53. So you always want to make sure that once you figure out the y value, you actually answer the question. So it says, hey, find my y value, but make sure that you use your function notation. So in order to do that, we are going to say that the function of g evaluated for x is equal to 8 is equal to my negative 5 over my denominator, which is 53. And so that is going to be my final answer. For number 3, we have a new function. That new function is now called h. So what we're plugging in now is a y value. So notice the difference between number 2 and number 3. For number 2, we were plugging in x into every time you see an x value, versus now in equation number or example number 3, we're plugging in a y variable. So the letters can change. Remember, it can be x or y or a or b or any letter in the alphabet, but it still means that you're going to be plugging in that value into your equation. So now you're going to say plug negative 8 is equal to your, and what you're plugging in now is a y value. So now you want to think about it as find your outcome. So what you're going to do is you're going to plug that in. So you're going to have a 4 absolute value. You're going to plug in your y value plus 2 minus 3. And of course that value, it's telling you it's going to be a negative 8. So now you can say, well, this is 4 times the absolute value of, and you have negative 8 plus 2, which is going to give you a negative 6, but it's going to be inside the absolute value, and then you have a subtract 3. So now for this function, remember this is multiplication, so you are going to multiply. So you're multiplying 4 times the absolute value of negative 6. So that's going to give you a 4 times, so the distance from 0 is going to be 6, since distance can never be negative. So now you know that 4 times 6 is equal to 24 minus 3, which is going to equal to 21. So now you have that when you plug in that negative 8, your value is going to be a positive 21. So when you rewrite it, your final answer should be that h of negative 8 is equal to a positive 21. Now, for number 4, they're just getting a little fancy with the notation. So here, for number 3, it says, hey, when you plug in negative 8 into your original equation, well, now this is saying that for the function h of x equals to negative t minus 1, evaluate h of t plus h of 2. So students, I just realized I made a small error on this worksheet. So notice here that I have the x value x. That should have been also the x value. So I'm going to skip this one because I did a typo. But number 5 is really, really similar. Well, you still have your input of a y value, so that's good, that matches. That was my mistake in the last problem. But now that you have your y value for your function is equal to the y variable inside of this right-hand side, then we want to evaluate n of y plus n of 1. So now, well, this is saying, hey, let's see what this happens. So we have our ny plus n of 1. So you think of this as just writing down my original equation. That's exactly what I have. So this turns into a 4 that's being multiplied by a 3y minus 8 minus 4. Versus, you still have the addition, so I'm going to copy that down, it's still addition. And we have our value, or function, being evaluated at 1. So I'm going to have my 4 times the absolute value of 3 minus 8 minus 4, where for that y value we are plugging in that 1. Well, for the first part, to evaluate the function at y, we left it as a y. We just copied down my original function. So n of 1 just means, hey, now plug in 1 into that function. So now I can say that this is going to be equal to, and now I just evaluate, right? So for the first one, it doesn't change much. You're just going to have 4 times 3y minus 8 minus 4. And you have our second part of the equation, which I have written in green. So here I can just compute. I can just plug this into my calculator or compute each part of it, right? So this is just going to be my 4 times the absolute value of, and I have 3 minus 8, which is going to give you your negative 5 minus 4. And so if I keep working on this, well, I know that the absolute value of negative 5 is just 5, since distance can't be equal. So now I'm going to have 20 minus 4 is going to give me 16, because 4 times 5 is 20, and 20 minus 4 is going to be 16. And the left-hand side didn't change much. I still have 4 times 3y minus 8 minus 4. So now that I have that 16, what I can do is actually combine that negative 4 and that 16. So I'm going to have this equal to a 4 times the absolute value of 3y minus 8. And I have my negative 4 plus 16, and that's going to give me to a positive 12. So now I know that my equation is going to be equal to a 4 times the absolute value of 3y minus 8 plus 12. That is going to be my final answer to n of y plus n of 1. For number 6, it kind of takes that same idea of whatever that value is that you're using. So for number 6, the value that we're using is going to be a, okay? So for the input variable, we're going to change all of those y's into a's. So I'm going to have that n of a is equal to 3 squared minus 8 parentheses minus 6. So what we're doing is we are plugging a into the equation. So we're going to plug a into every time we see the variable y. So now I'm going to have a 3a squared minus 8a minus 6. So we have that, and our function with a is going to be 3a squared minus 8a minus 6. And that is going to be the end of this section. If you guys have any questions, please feel free to email me or the Math Success Center or our embedded tutor. Thank you guys.